This one is a thing called a slip ring. A slip ring is when you want to take like an electronic spindle and put it in an endless circle. I don't know if there's that many in here, but most motors have something similar to that in like a brushes, where you just have these kind of like locking concave carbon interaction plates, and then you have like the spinning center, and they always need to be in electric contact. So right here in this print, you can see that there's two different kinds. There's ones with these lengths that allow you to nest a pin, and then there's these ones that don't have the length. So you can think that you take two of these in like eighth inch plexiglass, and then you put these lock washer ones on top and bottom of it. So with 4 layers, you have an inner ring that can do a slip ring mechanism. So if you wanted to do a VGA cable, that's like 15 different wires. But if all you wanted to do is like video and power, that's like 5 wires. So if you're going to make a 5-wire system, you need the bottom, first 2 layers, a barrier, a middle, another layer, a middle. So it's basically just X is how many layers you want, and you're going to need X times 2 of the running rings, and then you're just going to need X plus 1 of the top and bottom barriers. So that puts us at for a 5-wire system. Just puts us at 10 plus 6. Would be how many different of these plates you need to accommodate that. And the whole idea of these is that they're actually 2 different pieces. You're going to leave a little bit of a room right here between the 2 to put copper foil or just copper plate. And then there's going to be these little copper teeth that are just going to be running on the copper plate. And there's redundancy. Symmetrical redundancy, that way, you know, if this one's pushing too hard, then this one's lightening up. So the funny thing about this system, and a lot of my pin teeth systems, is just the tension of a lot of pins holds them in check, holds them in like a stasis between these rings. So here's like the first examples of intermittency cognos. These ones are just 3-sided, 4-sided, and they're just boring cut aparts. These are done manually in Inkscape or Corel Draw, where you just take like the component, which is like the whole ring of the cog, and then you just set a cut line on all the different places that you want to, and then just do a little bit of almost like a fish surgery, where you take out like a little piece of eyelid and you put in something that's like a cosmetic attenuator. And I can see that there's little mutations of like what a washer can do. Like this particular washer is the extension for the leg. Notice how like the leg is part. This was like the original design, was to put the leg on the gear, but I noticed if you do that, then it's a lock mechanism as well. So later ones put the actual kind of aesthetic of the, and also the weight of the leg on the topper layer. That way there's no dimensional interaction, which you'll see in Algo do sometimes. Hopefully the thing that you want to do for out of this computer session is that you play with Algo and create, just take screenshots of your coupler curves. And I can show you how to do that one more time before the end of the class. There's lots more to go over too, so, but we'll break in a little bit. But let's give Algo one more try, just so all 3 know how cool it is. But check out this list on Kinematics too, to see different things that I printed out. And you'll even see in the room. Here's like the printouts for the modular sets. Here's like a player piano roll I made. Here's close-ups on some of those laser core sections. So a print like this is actually for belts. So I'm just intentionally kind of printing a ring and then an outer teeth. Or actually inner teeth. You end up with an outer and inner all the time, no matter what. Sometimes you throw away half of your stuff because it's just the opposite angle. I started doing redundancy where I put like 6 bolts in the center, because sometimes like layered systems, you might want bolts to be going through to the left, and you might want bolts going through to the right for something else. So a lot of times, layer design has to do with almost, I don't know, it's a little bit like a video game. But if you think about making a 3D object, you're going to have to think about like, how are the layers connected. Sometimes there's going to be cavities. You can make any 3D object out of layers. But it's kind of fun. One example that's in this list that depicts that pretty well is my shoes. Oh, this is another example of those mighty tools in Illustrator to do transforms. They're called Pathfinders in Illustrator. If you took this picture that has like an overlap of a circle and a cog, you'd want to be able to like, extract the inner points that are useless or just like cut them apart. And so they have different kind of compost modes. You've probably seen compost modes in Final Cut where you're like adding two videos together. But if you think about vector composting, it can get kind of tricky. Like what would it really mean to add two things together? But they have like 8 different modes of pathfinding in Illustrator. And just the right one, they also have in Corel Draw. Just the right one can clean this picture up so that you get the outer ring, the inner ring, or the division of the two. This one's a good example of how to cast rings for jewelry. You'll need these barrier walls that leave a little bit of area for the wax to funnel over to. Right over here, and you're going to need the inner rings. You can choose a couple different ones depending on the size of the finger and whatnot. But these will just make ring blanks, and from there you can embellish them more. This is a laser core I did in a 3-sided mode, which is kind of different. It was a triangular piece of art anyway. So instead of making the ever-present grid, I tried to do this 6-sided form. This is another kind of player piano roll where it just had this was actually made in Max MSP. It's just an output of overlapping sine waves. And here's the exact same program, just with different parameters. Instead of perfect symmetry, then I just turned off some of the sine waves so that it was just fractions of them. And I believe I had to create this texture as a bunch of polygons, and then I had to transfer it into Illustrator to do the pathfinding, because it was a very strange pathfinding to get this to work. In Illustrator, the coolest tool that I have that's useful for doing laser cutting was the one that takes a line and actually turns it into, you can thicken up a line and then turn it into the 2 distinct lines that are the top and the bottom of it. So if you have a shape like this, then what it would do is first you thicken it up so that it would look like that. So it's like a thick brush. And then from there, you say extract outline. And then you convert this into like a nicely dilated contour that is the inside and the outside of the original one. Because sometimes you really have to translate positive to negative space. Otherwise, like if you were just directly laser cut this, you would just end up with a bunch of ribbons and a bunch of shards. It wouldn't have an intact oneness. So that's just that little outline trick in Illustrator is what gets that accomplished. But the one example that makes the most sense to show you, almost done for today here, is these shoes I made for my angle grinders. And all they are is just different plates that look like soles of shoes. But the funny thing was that with having to do 3 of them, I had to make room for the power cord. Here they are. So this is like the one that lets the angle grinder be over here. But then the power cord for it goes over to the right. And then on the lower ones, the power cord overlaps with the lower layers. So here's the angle grinder. Here's the foot. And then the planar model needs to accept like full ring, and then for this one it needs to make a cavity. So the wire that goes out the heel of the foot travels between layers, and some layers let it through. And then at the bottom, there's this hollow cavity that lets it out, and then it's flattened on the bottom, so it just has this like minute little tunnel specifically made for it. using like 3 or 4 different layers of foot panel. So it's probably added another 5, or added an inch or 2 to my foot. But just last time, make sure you guys know about AlgoDo. I made a car example in here. You have to press play, and then you can see the car walk around. And then it's got a point on it that keeps track of where it's at. Now it's hitting this wall, so it really doesn't have any power over there. Now this was done by putting a motor on one of the axles. I'll do it one more time. In AlgoDo, you can get springs, you can get ropes, you can make gears, you can put motors on gears, you can make rivets, lots of different tools. The sketch tool lets you do pretty much everything you'd want. And you can get a lot of fun accidentally just by putting a rivet or a fixate on a position that's not the center or something. So right now I need to draw that. Put 2 rivets on it. And then give one rivet a motor just by right-clicking on it. And saying motor, give it a left key and a right key. So it's kind of universally reprogrammed to your keyboard. And I think I clicked on motor. And now I give it a play button. This thing falls to the ground. And then I can start to give it a turn, but as you can see, there's something in the way. So let's see if I can get rid of this thing. See if I can get any leverage off this ground. I'm kind of trapped inside that car. Well, I'll get my car out of that car with the little grab. Zoom out, zoom in. The sketch tool even has some options. If you like triple click, then you can like change the camera to like drag around. But you should watch a tutorial about the the sketch tool, because pretty much everything you need to do in AlgoDo can be done with the sketch tool. All right, so my car's free now. Let's see if I can get any good traction with it. And for the coupler curve assignment, it's all about putting these color rivets on it. With the sketch tool, you can automatically make a color rivet by just doing like a spiral, a specific kind of spiral. So let's see if I can do it the first time. Yeah, so just keep spiraling, and it's like, oh, you mean that one. And you can use as many as you want. But for your first assignment, the way that I see it, like you make a drawing with the actual coupler curves with sticks and stuff, and just turn it in a piece of paper. And then if you use AlgoDo to do the exact same thing, I do have a couple links in here that on the website that will give you like 10 links to really cool things that have been done with AlgoDo to make like automated factory systems. And remember, you just right-click on these guys to lower their fade time so you can get the entire contour. It's pretty cool software. And of course, the world has gravity, so you could set up non-gravity systems and just have your motors be the only components that are involved. And you really got to watch out, like just like we're having fights with like overlapping layers, like you'll get to the same fights in this virtual space sometimes. So one option that you got to know about, last thing, is just right-click on it and check out the collision layers. See, now it says it's on layer A. So you have the option to say, I'm going to take it out of collision world, just take off all these, or you can set it up so that you have different layers, which is kind of like a pseudo 3D, like they are layers like a cake. Now there's a couple like just party favors. Like I just accidentally liquefied my gear, so they got a liquid system in here. You can make with the SketchUp tool, you can make a bucket. Like this is a 2-dimensional bucket that can hold water. All you got to do is put some above it and then say liquefy it. I don't know if there's liquefy. It's a drop-down menu thing. Aside from liquefy, there's also materials, and these are just just global representations of materials, and they will just default to these different preferences. So all they are is just a different looking texture and then a change to the physics parameters. So now it's rubber. So it might just have different bounciness at this point. Yeah. But you guys are welcome to hang out here, and like we have class time until 1. We have this room reserved, whatever that means. We hardly need all of it. But when you guys are done with lunch, we'll just hang out at the H101 room, just check in, and go from there. We've gone a little over. If you show up by 1:30, that's cool. Yeah. But just try to send yourselves an email with the different website pages I've shown you, so that you have a chance to check in on your own time. Luckily, this room is like free 24/7, but pretty much every program that we're using in here is free, so that you can go on your computer. Here's the physics one of Theo Jansen's piece. There is a plugin that just turns SketchUp into AlgoDo practically. Just the landing of the website that I want you to be aware of. So Kinematic 1, just without a 1 actually, just Kinematic is the first one. And that has a slew of all the pictures that I tried to communicate to you. Probably the best of the best, you know? Somewhere around here there's about 6 links to really good AlgoDo. But you think about it, like all these pictures right here, pretty much half of them you could just instantaneously create in AlgoDo and get the theoretical coupler curves that it accomplishes as just like printouts on your screen. So I think AlgoDo is the best one because there's other programs that do coupler curving, but they're just really lame. They're like 10, 20 years old and have horrible graphics. But yeah, Kinematic, and then Kinematic 2 and 3. And then the SketchUp Prez. If you wanted to download some of those ebooks, I recommend the top of this page. And then when we get to it, I'll tell you more about programs I've written for collision detection and stuff, and circuit design. And if you just draw that in, just kinematics, you'll get a list of all 700 of the files currently in store. These ones that say Cortex, text Cortex with weird numbers out of them are just like the laser cuts that I did that kind of like